Welcome to Session 2 of Unit 1 in learning the course Design and Analysis of Algorithms. In this session, we are going to discuss about pseudocode. In our previous session, we discussed what is an algorithm and what are the characteristics of algorithm. Now here, we are going to discuss about how to specify an algorithm. The main objectives of this session are to learn various algorithm specification methods and to know the syntax for writing pseudocode. The learning outcomes of this session are, by listening this session, one can understand what is pseudocode and one can able to write the pseudocode for the given application. The topics that we are going to discuss in this session are algorithm specification methods. Coming to algorithm specification methods, we have basically three algorithm specification methods. 1. Natural language specification, 2. Graphical specification, and 3. Pseudocode specification. What the three algorithm specification methods we have? Natural language specification, graphical specification, and pseudocode specification. Now I am going to explain about each and every specification one by one. Coming to the natural language specification. What is natural language specification? What is natural language specification? The steps in an algorithm can be represented by using natural English-like language sentences. What is natural language specification? The steps in an algorithm can be represented by using natural English-like language sentences. For explaining about this natural language specification, I have given an example here. Let us see the example. Consider preparing a cup of tea. What the steps that we are following for preparing a cup of tea? The first step that we are following is keep tea bag in the cup. Keep tea bag in the cup. The second step that we are following is add some water. Add some water. And the third step that we are following is let it boil for 5 to 7 minutes. Let it boil for 5 to 7 minutes. And the last step is add sugar, milk, etc. and serve hot. Here, what the 4 steps that we are following in preparing a cup of tea? Keep tea bag in the teacup, add some water, let it boil for 5 to 7 minutes. Finally, last step is add some sugar, milk or honey or lemon, etc. and serve hot. These 4 are the steps that we are following for preparing a cup of tea. You can observe the 4 steps that I written. All the statements are represented in general English sentences. All the statements are represented in general English language sentences. That is, this type of problems can be represented easily by using natural language specification. But if you want to use some complex mathematical structures, what we can do? This natural language specification is very easy to understand, but it is somewhat difficult to represent the complex mathematical notations such as trigonometric functions, logarithmic functions, sinusoidal functions, etc. The main advantage of this method is it is very easy to understand. Anyone who are seeing that particular algorithm, who knows that language, can easily understand that algorithm. But it is somewhat difficult to represent the mathematical notations. Now, coming to the graphical specification. What is graphical specification? The steps in an algorithm can be represented by using some graphical symbols. What is graphical specification? The steps in an algorithm can be represented by using some graphical symbols such as oval, circle, rectangle, square, parallelogram, etc. Now for explaining about that graphical specification, here I taken an example. That example is also a small example which is nothing but addition of two numbers. Now here this represents the algorithm in the form of graphical specification for finding the sum of those two numbers. Let us see the algorithm. Here start, enter integer a, enter integer b, c is equal to a plus b, and put the sum which is nothing but plus c, and end. Let us observe, for the representation of each step I used a specific graphical symbol. You can observe here the start and end of the algorithm is represented by using oval. Start and end of the algorithm is represented by using oval. The input, here A is an input and B is an input, and output, C is the output. The input and output are represented by using parallelogram. Input and output are represented by using parallelogram. And you can observe here the processing. The addition is done here. The processing is represented by using rectangle. The processing is represented by using rectangle. And here you can observe I represented the arrow symbols between each graphic. These arrow symbols are used for the representation of flow of control. These are used for the representation of flow of control. Right. Now here some more symbols you can use, such as circle. The circle can be used as the connector. So like that we can use various graphical symbols for the representation of steps in an algorithm in case of graphical representation. Now the flow of control can be represented effectively in case of this graphical specification, but it is difficult to represent some complex data structures such as graphs and trees. The main advantage of this method is flow of control can be represented effectively. But the drawback that is present in this is we cannot represent complex data structures, trees, graphs, etc. properly in case of this specification. Here, till now, we seen two algorithm specifications. One is natural language specification and other is graphical specification. Both are having their own advantages, their own disadvantages. In case of natural language specification, it is very easy to understand, but we cannot represent the mathematical notations properly. In case of graphical representation, the flow of control can be represented properly, but we cannot represent the complex data structures properly. So, in order to avoid all these drawbacks, we are moving towards the third algorithm specification, which is nothing but pseudocode specification. Now I am going to explain you the pseudocode specification. What is pseudocode specification? The pseudocode specification can be defined as the combination of natural language specification and programming constructs. What is pseudocode? The pseudocode specification is defined as the combination of natural language specification and programming constructs. Now here we need to follow some syntax for expressing an algorithm in pseudocode. What the syntax that we need to follow? Here I am going to explain you the syntax what we need to follow for expressing an algorithm in pseudocode specification. Let us see the syntax. Here first comments, how to represent the comments. In pseudocode, the comments begin with double slash symbol and continues till the end of that particular line. The comments begin with double slash symbol, they continue till the end of that line. If you want to represent another comment in the second line, Again, that should be started with another double slash. If you want to represent another comment in the second line, you need to start that comment again with double slash symbol. Next, blocks. What are the blocks? What is a block first? A set of statements is to be called as a block. What is a block? A set of statements is to be called as block. How to represent blocks? Blocks are indicated with matching braces, open brace and closed brace. Here this is the matching braces. One is open brace and other is closed brace. Within those braces, we are going to represent a set of statements. Within these braces, we are going to represent a set of statements which is to be called as a block. Third, identifier. What is the identifier? I think you may know the identifier. What is identifier? The names of variables, the names of functions, etc. are to be called as identifier. Whatever it may be the name that you want to represent in the pseudocode, which is to be called as an identifier. How to represent identifiers? Identifier begins with a letter. Always in case of pseudocode, the identifier begins with a letter, that is an alphabet. For example, I want to represent sum. I can write like this, or I can write like this. If I want to represent total, I can represent like this, or I can write like this. So anywhere, the identifier should begin with an alphabet or a letter, whatever it may be. It may be the lowercase alphabet or it may be the uppercase alphabet. And one more thing is, the data types of variables are not explicitly declared. So you have to remember this one. In case of your programming languages in C or Java or in something, you have to declare the variables before using them in your programming. But in case of pseudocode, no need of declaration of variables. The data types need not be explicitly declared. The next one, compound data types, such as structures and unions. Compound data types such as structures and unions, which can be represented in pseudocode by using record. Record is used to represent the complex data structures such as structures and unions. Now here you can observe the syntax for writing the record. Node.record. Within the braces, we represented various data items such as data type 1, data 1, data type 2, data 2, data type n, data n, and so on. N data items can be represented within those braces. And here you can observe link, a pointer variable, which is a pointer to the record type. And how to access these individual data items? How to access these individual data items from the record? We use two operators for accessing the individual data items. What are those two operators? One is arrow and other is period. One operator that we are going to use for accessing the individual data items from that record are, one is arrow and other is period. Next, period means just simply a dot. A dot is to be called as period operator. Next, 5. Assignment of values. Assignment of values to variables. Assignment of values to variables can be done by using assignment operator. What is the assignment operator? Just single equal. What is the assignment operator? Single equal is the assignment operator. By using this assignment operator, we can assign values to variables. Here you can observe, I have written variable is equal to expression. In the left hand side, I represented a variable. The right hand side, I represented an expression. This expression can be evaluated. After evaluating that expression, we will get some value. The value that I obtained is assigned to the variable which is present on right side. The value what we are obtaining by evaluating this expression is assigned to the variable which is present in left side. Next, Boolean values. We can represent two Boolean values in our pseudocode. One is true and other is false. For obtaining these Boolean values, we are using logical operators and relational operators. The most probably used logical operators are and, or, not. And the relational operators are less than or equal to, greater than or equal to, and not equal to. Here all these are the various logical and relational operators that we can use in our pseudocode to obtain the Boolean values true and false. Next, coming to looping statements, we can employ three looping statements in our pseudocode. The three looping statements are while, for, repeat, until. Here we can employ three looping statements while, for, and do while, which is represented with repeat until. Now let us see the while loop. What the syntax that we need to follow for writing the while loop? While condition do, within the braces we are representing statement 1, statement 2, so on, statement n. So here how this while loop is executed? First it checks the condition, whether it is true or false. If the condition is true, it goes for executing statement 1, statement 2 and so on, statement n. Again it goes for checking the condition. Again if it is true, the statements are executed. That is, as long as the condition is true, the statements 1 to n are to be executed repeatedly. Whenever the condition becomes false, the execution control comes out of the loop. Whenever the condition becomes false, the execution control comes out of the loop. How while loop is executed? As long as the condition is true, the statements 1 to n are repeatedly executed. Whenever the condition becomes false, the execution control comes out of the loop. Now I am going to explain the next looping statement, which is nothing but for loop. Let us see what the syntax that we are following for writing for loop in our pseudocode. For variable is equal to value 1 to value 2 do, within the braces we represented statement 1, statement 2, so on, statement n. How this for loop is executed? Initially, variable takes the value 1. Initially, the variable what we represented in left side, it takes value 1. The statements 1 to n are to be executed. As long as the variable value moves from value 1 to value 2, for that much number of times, if it takes 10 steps or 10 times to reach the variable value 1 to value 2, for these 10 times, the statements 1 to n are to be repeatedly executed. Whenever the variable crosses value 2, then the execution control comes out of the loop. For example, here I represented I is equal to sum 1 to 5. I is equal to 1 to 5. First I takes 1. For 1, all the statements are executed for one time. After that I takes 2. Again the statements are executed. Then 3. Again the statements are executed. Then 4 and 5. So for 5 times the statements are executed. Whenever I crosses that 5, the execution control comes out of the loop. Right. Next, coming to repeat until. This is equivalent to do while. This is equivalent to do while in our programming. Now, what is the syntax that we need to follow for using repeat until in our pseudocode? Let us see the syntax. Repeat statement 1 to statement n until condition. Repeat statement 1 to statement n until condition. Now, how repeat until is executed? First, statement 1 to statement n are executed. Statement 1 to statement n are executed. Then it goes for checking the condition. If the condition is true, then again statement 1 to statement n are executed. Again it goes for checking the condition. If it is again true, then statement 1 to statement n are again executed. Whenever the condition becomes false, then the execution control comes out of the loop. So, as long as the condition becomes true, the statement 1 to n are repeatedly executed, and whenever the condition becomes false, the execution control comes out of the loop. Now, I am asking you one question here. What the difference that you observed in while and repeat until? While and repeat until. In while, initially we are checking the condition, after that we are executing the statements. In repeat until, by default, one time the statements are executed, after that we are checking the condition. In case of while, without checking the condition, the statements are not executed. But in case of repeat until, for the first time, by default, the statements 1 to n are executed, then it goes for checking the condition. Both are entry loop, but entry controlled looping statements. Both are entry controlled looping statements. But here, the coming or going out of loop can be done by the condition. Here, after executing the statements one time, the condition is checked. Okay, I hope you understood all the looping statements. Next, we are going to see conditional statements. We can represent 3 conditional statements in our pseudocode. The 3 conditional statements are simple if else, case statement. Here these are the basic, but you can use some extensions for these. In case of if else, you can use nested if else or else if ladder, etc. also in our pseudocode. Now the basic conditional statements that I am going to explain here. So coming to simple if, what the syntax that we need to follow for simple if? If condition then statement. If condition then statement. That is, if the condition is true, then statement is executed. If the condition is false, then the execution control skips the execution of that particular statement. If the condition is true, then statement is executed. If the condition is false, then execution control skips the execution of that particular statement. Next, coming to if else statement. Here, what is the syntax for if else? Let us see. If condition then statement 1 else statement 2. If condition then statement 1 else statement 2. How it is executed? If condition is true, then statement 1 is executed and execution control skips the execution of statement 2. If condition is false, then statement 1 is skipped and statement 2 is executed. If condition is true, statement 1 is executed. If condition is false, statement 2 is executed. Right. The third one is case statement, which is equivalent to switch case in our programming. Now let us see what the syntax that we need to follow for writing case statement. Case, within the braces, we are going to write condition 1, statement 1, condition 2, statement 2, and so on, condition n, statement n, else statement n plus 1. How this case statement executed? Let us see. If condition 1 is true, statement 1 is executed. If condition 2 is true, statement 2 is executed. and so on. If condition n is true, the statement n is executed. If all the conditions are false, then the default statement n plus 1 is executed. If any of the conditions, here we have n conditions, any of those n conditions is true, that particular statement is executed. If all the conditions are false, then the default statement, which is nothing but statement n plus 1, can be executed. So all these three gives the basic conditional statements that we have. Let us see the next one, input and output. In case of pseudocode, the input and output can be represented by using the instructions read and write. Read and write. Read is the instruction which is used to represent input. Write is the instruction which is used for the representation of output. Now, finally, the algorithm consists of two parts. One is heading and other is body. Algorithm consists of two parts. One is heading and other is body. Now here heading takes a form which is nothing but algorithm name and its parameters list. Body is nothing but a block of statements which can be represented within the open brace and closed brace. But coming to heading is nothing but algorithm name and its parameters list which can be represented within parenthesis. That is, for example, if you want to write an algorithm whose name is sum. Suppose the name of my algorithm is sum. How I am going to write the heading? Algorithm sum. Within the parenthesis, we are going to write the parameters what we are passing to that particular algorithm. And coming to the body, within the braces, we are going to represent the statements what that are present in the body of the algorithm. Here, this gives algorithm header, this gives algorithm body. Right? I hope you all understood the pseudocode for expressing algorithms. Now I am going to show you an example how I represented that particular algorithm in pseudocode. Let us see that example. Here see the example, algorithm max of a comma n. Here a is an array and n is size of that particular array. Here you can see here, this is algorithm name. Here max is the name of the algorithm, a and n are the parameters, which entirely indicates algorithm header, which entirely indicates algorithm header. Here these indicates body of the algorithm. All these statements indicates body of algorithm. We have two parts in the algorithm. One is algorithm header and other is body of algorithm. Here this is algorithm header which contains algorithm name and its parameters list, and all the statements in that algorithm are represented within the body. Here this represents the body of algorithm. Now let us see, the first statement represents algorithm name. The second statement, which is nothing but comment. Here I described what is a and what is n there in the comment to better understand the algorithm. And third one, here block starts here. Block starting is indicated with this brace, open brace. And here I used an assignment operator. That is, the value which is present in a of n can be assigned to the variable which is nothing but result. Here the value a of 1 is assigned to the variable result. In the next statement, I used a looping statement which is nothing but for loop. Here in this for loop, the variable I takes the values from 2 to n. I takes the values from 2 to n. The next statement is I used a relational operator. I used a relational operator to obtain the Boolean value, whether true or false. Here I also used a conditional statement, simple if. I also used a conditional statement, simple if this entirely indicates a condition If this condition is true, then this statement will be executed. Now again I used here an assignment operator, and here finally the block ends with closed brace. Here you can observe this, what the syntax that we explained earlier, almost all the syntaxes that I followed to write in this algorithm. I hope all of you understood how to write an algorithm in pseudocode. Now I am going to summarize the concepts that what we explained in this session. In this session we explained about algorithm specification methods. Basically we have three algorithm specification methods. One is natural language specification, second one is graphical specification, and third one is pseudocode specification. Coming to natural language specification, all the statements are represented using general English-like language sentences. In case of graphical representation, all the statements in an algorithm can be represented by using some graphical symbols. Coming to pseudocode, which is nothing but the combination of both natural language and programming constructs. We also seen what the syntax that we need to follow for writing various statements in pseudocode specification. To assess yourself, I given some questions here. Let us see those questions and answer these questions. The first question is, in natural language specification, the algorithm can be represented by option A, general English-like language statements, option B, using some symbols, option C, using program syntax, and option D, using mathematical notations. The second question is, in graphical specification, the rectangle graphic used to represent option A, input, option B, output, option C, processing, and option D, flow of control. The next question is, in pseudocode specification, which of the following statements is wrong? Option A, comments begin with double slash. Option B, data types of variables should be explicitly declared. Option C, parameters list can be represented in the algorithm header. Option D, body of algorithm can be represented in between braces. The next question is, write and explain the syntax followed to represent an algorithm in pseudocode specification, and also write the pseudocode for finding the factorial of given number. And also here you need to justify what the syntax that you followed in writing this particular application, that is factorial of given number. In writing the pseudocode for factorial of given number, what the syntax that you followed, that should be justified for me, and share your answers through the given mail ID. And here in preparing this presentation, I used the digital content from various public sources. This is used only for educational purpose, not for any commercial purposes. Thank you for listening the session.